this is King of Review. Here we need to determine whether the infinite series given here is convergent. We know this is an infinite series because n starts at 1 and ends at infinity, so it goes on forever. Convergent means that this series would equal an actual sum. We could figure out, using limits, the sum of this infinite series. It wouldn't just keep changing as soon as we add another term. It would actually converge to a single number as its sum. So, the way we can figure out if it's convergent is to take a look at the series and see how each term changes when it goes to the next term. So this series has 3 times negative 1 to the n minus 1 power, where n starts at 1. So I'm going to plug in 1 for n. For the next term, we'll have the same expression, but I'm going to plug in 2 for n. For the next term, same expression, but we'll plug in 3 for n. And then 4 for n. And so on. This series goes on forever. It goes to infinity. But let's see what we have for these first 4 terms. 1 minus 1 gives us a power of 0. 2 minus 1 gives us a power of 1. 3 minus 1 is 2. And 4 minus 1 is 3. So let's see. Negative 1 to the 0 power, just like any number to the 0 power, is 1. Negative 1 to the first is negative 1. Negative 1 squared is positive 1. Negative 1 to the third is negative 1. And so on. So we get 3 plus negative 3 plus positive 3 plus negative 3, and so on. This series will continue to alternate between 3 and negative 3. Which means to get from one term to the next, you always multiply by negative 1. A positive times a negative is a negative times a negative is a positive, and so on. We always multiply by negative 1. This number, negative 1, is called r. Our series is called a geometric series because from every term, you multiply by the same number to get to the next term, r. A geometric series always multiplies by some number r. We always multiply each term by negative 1 to get to the next term. And a geometric series will converge if this property is true. The absolute value of r is less than 1. If that's true, the series will converge to a single number. Otherwise, it will diverge. It will continue changing for every term added, and we'll never be able to figure out one specific number for its sum. Well, if r is negative 1, the absolute value of negative 1 is positive 1. And if we want 1 to be less than 1, that is not true. 1 is not less than 1. This condition does not hold, so our series will not converge. And you can see that just by looking at the formula. In the first 2 terms, the sum, 3 plus negative 3, is 0. If we add on a third term, the sum is 3. If we add on a fourth term, the sum is 0. The sum will keep alternating between 0, 3, 0, 3, 0, 3 forever, and we'll never be able to express the entire infinite series as a single sum. It'll either be 0 or 3, depending on where you stop. So the series diverges. Thanks for watching.